The good thing about 5.3 is that it deals with three shapes that you have learned since 5th and 6th grade. The only issue is that we are going to be more specific about the properties of each one of these shapes that you already know. The first thing I need to say about these three shapes, these special parallelograms, is that they are all parallelograms. Bless you. So if you go back to 5.2's notes and you remember those properties that were in 5.2, all those properties are true about the rectangle, the rhombus, and the square. So opposite angles are congruent in a rectangle, and same thing goes for opposite sides are congruent in a rhombus, and so on. So don't forget that these properties also apply to these three shapes. Now, the definition of a rhombus is a parallelogram with four congruent sides. So if I have four congruent sides and it's a parallelogram, it's a rhombus. Rhombus you could think of as a diamond shape. I also think of it as a square that doesn't have the right angles. I can think of a perfect square and just let it move a little bit. So here are the three properties that are unique to a rhombus, and I'm going to draw them in there with you. That first and foremost, the diagonals are perpendicular, and each diagonal bisects their respective angles, and the diagonals bisect each other. Let's talk about what that looks like. I'm going to use this real ruler, and I'm going to go from here. Well, at least I thought I was. Let's try that again. There's a diagonal. And I'm going to do another one. Let me go up here and grab another line and pull it from here to there. These are two diagonals. The diagonals are perpendicular, which means that it doesn't matter which corner you pick, this one or this one or this one, they are all going to be 90 degrees. They're perpendicular, 90, 90, 90. Or I'll put the box, 90. They also bisect their respective angles. Now here's the interesting thing about a rhombus. This angle over here, I'm going to put a single arc, is going to be the same as this single arc over there. This diagonal cuts that angle into two equal pieces. And if I remember earlier that parallelograms have opposite angles that are congruent, these angles here are going to be the same on the opposite side. Whatever they are, they're going to be congruent. You can almost think of it as the isosceles triangles, where two sides are the same, the two angles have to be the same. Because it's true. And these angles here gets bisected. So I'm going to put a double and another double right there, and then a double and another double right there. Singles are congruent to singles. Double arcs are congruent to other double arcs. They're all going to be the same as each other. Lastly, the diagonals bisect each other. This diagonal cuts that into two equal pieces. I can say these two are the same, and these are going to be the same as well. That's what's special about a rhombus. What's special about a rectangle? Definition of a rectangle is it has four right angles. 90, 90, 90, 90. It has to be a parallelogram with four right angles. The diagonals are congruent. So if I were to take the same thing I did before and actually connect this diagonal to that diagonal, this other diagonal to that diagonal, those diagonals are going to be congruent. It's the only kind of parallelogram that actually has these diagonals being the same length as each other. Otherwise, it would just be a parallelogram. The diagonals bisect each other, and the diagonals are congruent to each other. The last one is the square, and the square has four congruent sides and four right angles. It's kind of like the child of these two things together. You had a rhombus, the rectangle, they got a little funky, and then they came out with this. It's a little mixture of mom and dad, right? It has 4 right angles and it has 4 congruent sides, and so it's going to have some of the same properties of these and these. The diagonals are congruent. Let me just draw a couple things in there. Let's draw some diagonals from here to there, and let's draw another diagonal from here to there. The diagonals are congruent. The diagonals are perpendicular, so here we have another 90. They're perpendicular to each other. These are all going to be congruent, just like a rectangle. We actually will know that this gets cut in half. It's 45 and 45 and 45 and 45 and 45 and 90 in the middle. A square is also always a rhombus and a rectangle. So if I know those properties, I'll be able to answer every question that's in your homework. As a matter of fact, most of your homework questions, you're going to have to decide whether the things are congruent or whether they are complementary. It's rarely supplementary, but sometimes you might add to 180. It's possible. Okay, let's do some examples. You have a worksheet in front of you. I chose number 3, number 7, 14, and 17. Number 3 says, decide whether the parallelogram is a rhombus, a rectangle, or square. When I look at this, I go, there's only one 90-degree angle there. Parallel, parallel. Well, if that's 90, then over here, let's see, they have to be parallel, transversal. This must be 90. So I could, I know that that has to be a 90-degree angle. This is congruent to that. So that must mean that there's other right angles over here as well. What shape is this? It's a rectangle. It has 4. It has, where's my eraser? There it is. Has 4 right angles. Because this is congruent to that, and you have 90 and a 90, there's no other angle that this could be other than a 90 degrees and a 90 degrees. It's not possible. Scooting over to number 7. This is how the majority of your problems are going to look for a rhombus. It says, find the measures of the numbered angles in each rhombus. You're going to have to figure out what the measure of angle 1 is, 2, 3, and the measure of angle 4. And they have this 1, 2, 3, 4, and then they give you one piece of information, the 68 degrees. So what I would always suggest to you is to start with this middle angle first, angle 4. Why do I start with angle 4? Because I know that the diagonals of a rhombus are perpendicular. What does that mean? Angle 4 needs to be a certain measurement. If you know what that measurement is, go ahead and say it out loud. 90. About 3 of you know. That's good. 90 degrees is correct. If you don't know, the diagonals of a rhombus are perpendicular. We wrote that down as its first fact. I would always start with that because then it kind of will lead you to the other angles. The second angle that I would do is I know that diagonals bisect the angle, meaning if this is 68 degrees here, this diagonal cuts it into 2 equal pieces, so this other angle here needs to be 68. And diamonds are perfect. So the 68 and the 68 need to match on the other side. I bet you we could figure out what angle 2 and angle 3 are. I bet you those are going to be 68 and 68 because they'll match. Why? Think of it as an isosceles triangle. 2 sides are the same. The 2 angles have to be the same. 68, 68. Now angle 1 is the one that I'm going to find last. I have a 90, I have a 68. These three are add up to 180, or I can say the 68 and the 1 are complementary, adding to 90. So I'm going to put off to the side angle 1 plus 68 degrees should equal 90 degrees. I can just subtract the 68 to figure out what angle 1 is. 22? Yeah, you agree? 22 degrees is what I'm getting for angle 1. Any questions? 2 more examples. Number 14. Classify each of the following parallelograms as a rhombus, a rectangle, or a square, and explain. Parallel, parallel. So it's definitely a parallelogram. Diagonal, diagonal, perpendicular diagonals. It's definitely a rhombus right now, but based off of this, it's a rhombus. But it also tells me that AC is congruent to BD. This diagonal is congruent to this diagonal. The only way that the diagonal will be congruent to the other diagonal if it's at right angle is if this is a certain shape. It's only if it is a square. It says, oh, it's a square. And how do I know it's a square? Diagonals are perpendicular and congruent. Because they're congruent, it makes it a rectangle. Because they're perpendicular, it makes it a rhombus. The only thing that's a rectangle and a rhombus is a square. Last example. Number 17. For what value of x is the figure the given special parallelogram? It needs to be a rhombus. They tell us this is 2x minus 1. This other one's a 4x plus 28. They want to know what x is equal to. Well, if it's a rhombus, this is sometimes what I do. I go, okay, it's a rhombus. All 4 sides have to be the same. And that kind of helps me because then I see an isosceles triangle. 2 sides are the same, which must mean that 2 angles have to be the same, that this angle here has to be the same as this angle there. And if that angle is 2x minus 1, so is this angle over here. Well, if those are the same and this makes a triangle, then the 2x minus 1 plus the other 2x minus 1 plus the 4x plus 28 should add up to be 180 degrees. And so I'm going to put these together. 2x, 2, 3, 4, 8x. 28 minus 1 is 27, minus another 1 is 26, equals 180. I'm just adding them up together. Subtract 26 from 180, I get 154. This is an excellent time to pull out my calculator, which is what I'm doing. And then what I'm going to do is take that 154 and I'm going to divide it by 8. If it does not go in evenly, don't worry. This one comes out to be a decimal. I would accept it as a decimal or as a fraction. Either answer is correct. 19.25 or 77/4. We'll stop your notes right there.